Okay guys, so we are going to start our discussion on Dbms module 3. Okay, so first of all, our topic starts with functional dependency. So to understand this, first let us understand what do we mean by super key. Super key, okay, fine. And when you learn super key, then only you can learn about candidate key. Okay, so first let us start with the discussion of super key. What do you mean by super key? So super key can be an attribute or it can be a set of attributes that uniquely identifies each of the record of a relationship. So let's give an example for that. Let us consider a table example itself. That is, we have SID, then we have name. I am considering a table example. SID is the name, is the marks is the department is the. This is just a table example. These are the different attributes here. Course, fine. Now let us write 1, 2, 3, 4, 5 some data in each of them. A, B, C. Then marks as 78, 60, 78, 60, 80. Department CS, triple CS, triple IT. This is my department. Fine. Now courses I can write it as C1, C2, C2, C3 and C2. Let us see. These are different records. Okay. Now super keys, it can be an attribute or it can be a set of attributes that can identify this relationship. So that means in this relationship, if I say SID can uniquely identify this relationship, I can say, okay, when I say SID number 1, can I get the data of one thing only here? Everything, name, marks, department, goes, yes. When I say 2, can I do that? Yes. But when I'm saying, so I can say this SID can be a super key because it uniquely identifies the record. Can name be a super key? When I say A, can I get all the details? I can get all the details, but there are 2 A. So which A we will choose? Which record? So I cannot say that name is a super key, right? This cannot uniquely identify this relation. Now let us say marks here also 78 is there, here also 78 is there, here 60 is there. Can it uniquely identify? No. Now can I take department which can uniquely identify? No, there are 2 CS. Course also I cannot take single. Now I can say, now consider this, SID comma name. Can this uniquely identify? Yes, because 1A and it is 3A here. Together SID and name can, 1A is a unique thing that can identify this relation separately. If I say 3A means, then only I will take this record. When I say 1A means I will take this record. So that means this SID and name can uniquely identify a relation. So there can be lot of possibilities. SID, name, marks can be another possibility of super key. So a super key means what? It can, which can uniquely identify. It can be an attribute or like this, a set of attribute which can uniquely identify. This is marks. Let us see marks here. Okay, uniquely identifies an attribute in a relationship. Fine. It can uniquely identifies a record in our database. Fine. So this is what super key means. Now you have to understand how can you find the max super key. So there is a max number of super key. You have to understand that max super key. Now let me just give another page. There's an equation, just learn that equation like this: max number of super key. For that there is an equation that is 2 raised to n minus 1, where n is what? The number of attributes there. Fine. Now this is the max super key formula, 2 raised to n minus 1. That means here n is the number of attributes. If a table has n attributes, every non-empty subset of attributes can potentially be a super key. That is what this means. So max super key is 2 raised to n minus 1. Fine. Now there can be a thing that we have to understand. What is candidate key? So in order to understand what is candidate key, so now we understood super key. If you have any doubt in super key, you can tell. Super key, if I'm considering another example here, this is a relationship. Okay, so here what are the super key? Can a can be a single a can be a super key? No. Single b can be a super key here? No. Now a b, like if I'm taking a and b, a1 b1, a2 b3, a1, so a b can be a super key because it can uniquely identify this relationship, right? B alone can be a super key, b1 b3, no, there are two b3, so it cannot. So this is what do we mean by super key. Now candidate key means, now let's understand what do we mean by candidate key. Candidate key, that is C key I am writing. Candidate key is a minimal of the super key. Okay, super key whose proper subset is not a super key. Candidate key's formula, definition is that candidate key is a super key. It is a super key whose proper subset is not a super key. That means super key whose proper subset is not a super key is called as our candidate key. That means if I am saying one example here, one relation example itself, if you want, we can take for a candidate key. So if I consider this example, this is a comma b. I said this is a super key. Now can this be a candidate key? So candidate key is also a super key. It is also a super key, but whose proper subset is not a super key. That means now a comma b's proper subset is what? A is a proper subset of a comma b. B is a proper subset of a comma b, but ab cannot be taken. Then it becomes subset. Right? Proper subset means we cannot include the complete set. Right? So here a and b are the proper subset of this super key. Now check if a and b are super key. If you see a is not a super key in this relationship, b is not a super key in this relationship, right? So that means this a comma b can be what? A candidate key. If you doesn't understand, let's consider one example here. That would be let's say one example. I'm going to take an example for understanding the candidate key case. Okay, so let me find example, guys. Just wait a minute. So in order to understand candidate key, let's consider here itself some example is there. Okay, this is a okay, let's just right now you have to understand candidate key. I hope you have understood with this example, or if I want I can give another example here. A is there, B is there, C is there. Let's say 1 2 3 4. B I am saying it as 1 1 1 3 4 5 7 4. Okay, let's say something like that. Now in this relationship, what are the super key? A is a super key. It can uniquely identify. Yes. Is B a super key? No. Is C a super key? No. There are 2, 4. Now A comma B can be a super key. That is AB can be a super key because 1 1 2 1 3 1 4 3 are unique, right? Now AC can be a super key, right? That is, if you see 1 4 2 5 3 7 4 4 4 4, right? So that means this relation can uniquely identify. But B in that means there is nothing repeated. 1 4 is there repeated anywhere? No. 2 5 anywhere repeated? No. 3 7 anywhere repeated? No. 4 4 anywhere repeated? No. It can uniquely identify this relation. So here these are the super keys. Now which would be the candidate key in here? The minimal of a super key and their subset, that is their proper subset, is not a super key. So means A, if you consider just single thing, so we cannot, it doesn't have a subset, right? Proper subset. Now A comma B, if you consider, so A can be what? A candidate, because it is single one can be a candidate key, that you have to understand. Now AB consider their proper subset is what? A and B. Now the proper subset should not be a candidate key, is a not a super key, is a condition of candidate key. Now if you see A and B, A, if you see, it is a candidate super key, you know, A is a super key. So that means this condition, B is not a super key but A is a super key. That means this cannot be a candidate key. Now similarly AC, what is a proper subset of A and C? AC is A and C. Now again, A is a super key, so this cannot be a candidate key. So the only candidate key in this relationship is A. Though A, AB and AC are super key, but A is only the candidate key, because here in AB and AC their proper subset is a candidate key. Here here it is a candidate, it is a super key. A is super key, so proper subset should not be a super key, is a condition of becoming a candidate key. So AB's proper subset A is what? A super key. Similarly AC's proper subset A is what? It is a super key, so it cannot be a candidate key. So this much if you understood, it is much more, we can easily understand functional dependency. So right now we have learned about what do we mean by super key and what do we mean by candidate key in detail, right? So if we know this clearly, then we can only understand functional dependency. Okay, thank you.